Hello everyone, welcome to my channel. Let's learn computer science.
Hey everyone, welcome back to a new video. Do you know in which language does the CPU actually understand instructions? Can the CPU understand Python? Can it understand Java or even C++ or maybe the language that we speak like English? Well, the answer is no. CPU can understand only one language and that language is called machine code. So in today's session, we are going to understand what machine code is, what assembly language is, and the relationship between assembly language and machine code. So let's get started. First of all, what is machine code? Machine code is the only language that a CPU can directly understand and execute. Basically, it consists of binary instructions which are made up of zeros and ones. For example, an instruction may look something like this: 1011000000110001. Now, just by looking at this binary sequence, can you tell what operation it performs? Probably not. And that's exactly the problem. Each machine code instruction tells the processor to perform a specific operation, such as loading data, storing data, adding values, jumping to another instructions. So you can think of machine code as the CPU's native language. Just as the humans communicate using languages like English or Hindi, the CPU communicates using binary machine code. So, important key points about machine code is that it is CPU's native language. It is written in binary, that is zeros and ones. Different processors, very important. Different processors, they have different machine code instructions. So it is not same across. Programs must ultimately be converted into machine code before execution. So in whatever language you are writing any program, that is ultimately converted into machine code so that CPU can understand it. Now imagine writing an entire software application using only zeros and ones. Sounds difficult, right? So writing programs directly in machine code is extremely challenging because machine instructions are not easy for humans to understand or remember or read. As a result, writing programs becoming very time consuming. So these are some limitations of machine code. Time consuming to write, difficult to understand, difficult to debug and maintain, and more likely to contain errors. So programmers needed a more human-friendly way of writing programs. That is why we have assembly language. Now, what is assembly language? Assembly language is low-level programming language that was developed to make programming easier while still allowing direct control over hardware. Instead of writing long binary sequences, assembly language uses mnemonics. Mnemonics are short, meaningful abbreviations to represent machine code instructions. For example, LDD stands for load data, add, addition, sub for subtraction, STO maybe to store data, JMP to jump from one place to another. Now compare these instructions. LDD total, add 20, STO total. Don't these look much easier to understand than pages filled with zeros and ones? That is precisely why assembly language was introduced. Right? Now let's have a look at the relationship between assembly language and machine code. Assembly language is essentially a human readable representation of machine code. For every machine code instruction, there is a corresponding assembly language instruction, or you can say for every assembly language instruction, there is a corresponding machine code instruction. The structure of both instructions is same because they represent exactly the same operation. But the difference is that machine code uses binary values and assembly language uses mnemonics. For example, if we are writing assembly language like LDD total, it has its equivalent binary instruction where it may be that this part is representing LDD and this part is representing total. Similarly, for add 20, maybe this part is representing add and maybe this part is representing 20. You never know, right? So assembly language makes programs easier to write, but the CPU cannot execute assembly language programs directly. So before execution, assembly language must be translated into machine code. And for that purpose, we use assemblers. In order to convert an assembly language program into machine language, we use assemblers, right? Now, as I said earlier, that assembly language and machine code, they are processor specific. They're not same across all systems. For each CPU, it is different. This means different processors have different machine code instruction sets. Each processor has its own assembly language, and an assembly language program written for one processor may not work for another processor without modification. Okay. So if the CPU cannot understand assembly language directly, who converts into machine code? The answer is assembler. An assembler is a translation program that converts assembly language instructions into machine code instructions. The process is very straightforward. First, the programmer writes the assembly language program. The assembler then translates it into machine code. And then finally, the CPU executes the machine code instructions. Okay. The assembler simply replaces each mnemonic with its corresponding machine code instruction so that CPU can execute the program. Let's understand about opcode and operand. Most assembly language and machine code instructions, they consist of two parts. First is opcode and second is operand. The opcode specifies the operation to be performed. For example, addition, subtraction, load, store. And operand specifies the data, value, register, or memory location used by that operation. For example, add 20. Here, opcode is addition, which is add, and operand is 20. So, addition is performed on operand, that is 20. In LDD total, opcode is LDD and operand is total. Total may have some value in it, right? So, this is explained here as well. So, this is your assembly language mnemonics where LDD is the opcode, total is the operand, and in machine code also, first part is opcode and second part is operand. If we talk about similarities between assembly language and machine code, both represent same processor operations. Both are specific to a particular processor architecture and both work very close to the hardware. Each assembly language instruction corresponds to a machine language instruction and both contain opcode and operands. But if we talk about their differences, assembly language uses mnemonics, whereas machine code, it uses binary digits. And assembly language, it is easier for humans to read and write, but machine code, it is difficult for humans to read and write because it is all in zeros and ones. Assembly language requires an assembler for translation, whereas machine code is directly understandable by CPU, so it can be directly executed by the CPU. Assembly language is human friendly and machine code is CPU friendly. Okay. So looking at similarities and differences, there are some advantages of assembly language over machine code and vice versa. But let's have a look at assembly language advantages over machine code. So it is easier to read and understand. It is easy to write programs in assembly language, easier to debug and maintain, uses meaningful mnemonics instead of binary numbers, and it still allows direct control of hardware operations. Right? And if we talk about machine code advantages, then it is more close to the hardware. It can be directly executed by the CPU. But assembly language, it requires an assembler, right? So that's all for today. Today you have understood the relationship between assembly language and machine code. In my next video, I'll clearly tell you how assembler works and how exactly a program is translated by assembler. Till then, take care and keep revising. Happy learning. Bye-bye.